This lecture is how the Milky Way formed and what the future is going to be like for our Milky Way. The formation of the Milky Way is really an unsolved problem for astronomers. Astronomers believe that the galaxy formation is basically a lot like star formation. You have a big cloud, gravity pulls it all together, and it breaks up into stars. Another key thing that astronomers are currently looking at are supermassive black holes. We tend to find supermassive black holes in the center of each galaxy, so there's a lot of research into going into researching the supermassive black holes and see what their role is with the formation of galaxies. To form a galaxy, though, the cloud would have to be perhaps 1 million light years across and contain 100 billion solar masses of gas. The most important piece of evidence that supports the idea that galaxies come from gases has to do with our population 1 and population 2 stars. Remember the difference between the two. Population 1 stars are young stars. They have a lot more heavy elements than the population 2 stars do, and they're typically found in the disk of the galaxy. Whereas population 2 stars are old, they don't have a lot of heavy elements, and they orbit in highly elliptical paths, and their orbits are also inclined with relation to the disk. Remember, this is our central bulge in our galaxy, this is our disk, and the population 1 stars are located in our disk, and the population 2 stars are at highly elliptical orbits and on an angle. In 1961, some astronomers proposed that the population 2 stars, being the older stars, formed in the first stages of the gigantic gas clouds. The gas clouds had a mass of about 10 to the 11th solar masses and was composed of almost pure hydrogen and helium. The early collapse was very slow, lasting as much as a few 100 million years. Massive stars that formed in the early stages of the galactic nebula collapse consumed their fuel and exploded as supernovas before they reached the center of the galaxy. The gas they ejected was rich in heavy elements and mixed with the other gases in the galactic nebula. These massive stars made up the first population stars, but are not population 1 stars. Population 2 stars then formed, and they contain trace elements of the heavy elements that were leftovers from the population 1 stars. After this first phase, enough gas was left over to form a rotating disk. The disk gas was rich in heavy elements from the deaths of population 2 stars. Since the disk started rotating, stars followed the path of the rotating gas. This accounts for the population 1 stars lying in the disk of the galaxy. According to this model, all population 2 stars should have about the same age, but they don't. Dun dun dun. Observations show that population 2 stars formed over a much longer time span than the model predicts. The model also predicts that there should be some stars that have virtually no heavy elements. All stars in the Milky Way galaxy have some of these heavy elements. Finally, the model omits the possibility of collisions of galaxies. From observations of young galaxies about 5 billion or more light years away, astronomers find that many young galaxies are much smaller than the Milky Way. There are also many instances of 2 galaxies in collision. Despite some weaknesses in the model, it does explain well many of the features of the Milky Way except for one. The Milky Way lacks stars that have virtually no heavy elements. These hypothetical stars would be called population 3 stars. It is possible that the population 3 stars would be contaminated with heavy elements from the gas and dust from supernova explosions. It is also possible that the conditions in the very early galaxy might have allowed only short-lived massive stars to form. The gas may have been too hot or too turbulent for the formation of the stars, having a lack of heavy elements. As the galaxy ages, its gases steadily forms more stars. These stars return some of the material to the galaxy in the form of gases ejected in their deaths, such as in supernovas, novas, planetary nebulas. Some of the masses of these stars, however, becomes locked up in stellar remnants like white dwarfs, neutron stars, and black holes. These 3 will never eject their material back into the galaxy. Eventually, the Milky Way will use up all of its gas and be unable to make new stars. At that time, billions of years from now, our galaxy will contain only dead stars and dim, low-mass red dwarfs, whose lifetime is hundreds of billions of years. Gradually, even these red dwarfs will burn out, and the galaxy will fade from view of astronomers in other galaxies.